got about here Friday going over the review sheet? Yes? Now, we're going to finish up the review sheet today, going through the rest of them, and then your test will be tomorrow. Now, I know that there is inclement weather coming in, and just with how the schedule is going, the test is going to be the next school day. So if we're not in here tomorrow and the next day is Friday, we'll be testing Friday. Okay? Now, looking at these here, there were two different ways we talked about special right triangles. Because we had the calligraphy pen. 45, 45, 90. And if we were given the leg, one of the sides opposite the 45 degrees, while the other side opposite 45 degrees was the exact same. And to find the hypotenuse, we took the length of the leg and multiplied it by the square root of 2. Now, if we were given the hypotenuse, well, to find the length of the leg, we took the hypotenuse and divided by square root of 2. And we got the answer for the other two sides, because the other two sides would be the exact same. Now, for our other triangle, we had the 30, 60, 90 right triangle. And if we were given the side opposite 30 degrees, the short side, well, the long side was the short side times square root of 3. The hypotenuse, guys, was the short side times 2. The other case that we could have is the long leg, the long side, the side opposite the 60 degrees. And the first thing we would do is to find the short. Well, the short side was the long side divided by the square root of 3. And the hypotenuse is short times 2. And the last setup we had was if we were given the hypotenuse. Well, again, the first side we find is the short, which is the hypotenuse, divided by 2. And to find the long, we take the short and multiply by the square root of 3. And these are kind of the shortcuts to get there. But on Friday, as we saw, we could actually use sine, cosine, and tangent and get to the answers just as fast, or just as well. Not so much as fast. Now, if we look at number 21, we do have a 90-degree angle and a 45, so it means the other angle has to be 45 degrees, which tells us that the value of x and y are going to be the same. And I think we did. Now, we can take the hypotenuse and divide by the square root of 2 if we're going by the shortcut. And if we do that, we would get 2 square root of 2. And we could have also done this using sine, cosine, or tangent, saying sine of 45 is equal to the opposite side over the hypotenuse. Well, the hypotenuse in this case, it is 4. And the opposite side, guys, well, we can call it x. We could have also called it y, because the two other angles in this triangle, the two angles in the triangle besides the right angle, because we don't use the 90-degree angle for these here, if it's this 45, then the opposite side is y. If we use this angle over here, then the opposite side is x. So really, for this 45, 45, 90, since both of those are 45, we could use x or y, because again, we know those two sides are going to be the same. Now at this point here, we would multiply both sides by 4, which would tell us that x is equal to 4 sine of 45, and when we plug that in, we get 2 square root of 2. So both sides are 2 square root of 2. So if the shortcuts make sense and you can utilize them, utilize them. But we can still solve it using sine, cosine, and tangent. Any questions on 21? Let's look at 22. 22 we can see is the 30, 60, 90, because we do have a 30-degree angle and a 60. And it's telling us that we do have a side length of 14. Well, 14 is the hypotenuse because it's opposite the right angle. Now, if we were using the shortcuts, well, the short side length is half the hypotenuse, 7. And since y is opposite the 30-degree angle, it's the short side, because we take 14 divided by 2. And to get x, the long side, we take 7 and multiply it by the square root of 3, which tells us x is 7 square root of 3. And that's it. And that's, again, just going based off the shortcuts. If we were using sine, cosine, tangent, well, we know 14 is the hypotenuse. So out of the 3 trigonometric functions, we can't use tangent. We could say sine of 30 degrees is equal to the opposite side length over the hypotenuse. Well, our opposite side length would be y, and the hypotenuse is 14. Here, y and x make a difference because both angles are not 45. They're 30 and 60. They're different. Our next step would be to multiply both sides by 14. 14 and 14 would cancel, telling us that y is equal to 14 sine of 30 degrees, which would be 7, because it actually works out sine of 30 degrees is 1/2. So y is 7. Now at this point here, we could do the same thing with either taking sine of 60 degrees or cosine of 30 and finding the value of y. Or we could use the Pythagorean Theorem because we do have 2 sides in a right triangle. We could use it. Now if we said cosine of 30 degrees, well, cosine is adjacent over the hypotenuse, adjacent side over the hypotenuse. Well, at this point here, again, we would multiply both sides by 14. These would cancel, telling us x is equal to 14 cosine of 30, and that x is equal to 7 square root of 3. And the reason this works out is that actually cosine of 30 degrees is the square root of 3 over 2. And that's all we have to do for this here. Any questions on these here? Any other questions on these special right triangles? Now again, on the, well not again, but on the test, because just like the note sheets, most of the directions are almost the exact same. Yes. Here it tells us that find the side lengths given the special right triangles, yes? So most likely it'll have that header letting you know that these are special right triangles for the next ones. Any other questions on the special rights? So if we feel comfortable with these here, because I included a bunch, we can look at 28 and 29. These here are the exact same. Now these here, we're not actually asked to find any of the angles or side lengths. All 3 side lengths are given, yes? Find sine, cosine, and tangent as a fraction of each acute angle. So we can look at 28. So sine of A. We're looking at sine of angle A. Well, it's opposite over hypotenuse. The opposite side for A is, and the hypotenuse is 97. Cosine of A would be the adjacent side over the hypotenuse. So well, we know the hypotenuse is still 97. So it would be 72. And lastly, tangent of A, opposite side over the adjacent. So on these here and on the test, it's looking for sine, cosine, and tangent of both angles. The only one we don't use is the right angle. Whichever one's the right angle is the only one we're not going to find these ratios for. 72 over 97. Cosine of C is going to be adjacent, which is now 65 over. And lastly, tangent of C is 72 over 65. And we can leave it like that. Because this here is not asking us to reduce, and it's not asking us to actually find the decimal. So that's it. That's all we have to do. Any other questions on 28 or 29? All right. Back up. So the next part is to evaluate each expression to 4 decimal places. Evaluate each expression to 4 decimal places. Well, the first one we have is tangent of 49.8. Well, we can pull the calculator up and say tangent of 49.8. Enter. That's it. I mean, we can do the same for sine of 61.72. Sine 61.72. .8806. And that's it. We would do the same with cosine. We would do the same thing for tangent of 38 over 24. We would do the exact same thing for all of these here. We're just plugging these into the calculator and letting it give us the answer. Out of these here, sine, cosine, and tangent, which is the only one that can give us a number greater than 1? Tangent. It doesn't have the hypotenuse in the denominator because the hypotenuse is understood to be the biggest side. So sine and cosine have to be less than 1. And again, this is talking about sine and cosine, not their inverses. Any other questions on 30 through 35? (36) through 41, we are not evaluating these. Because when we talk about evaluating, we're actually getting an answer. Like the last ones we did with tangent and sine, we evaluated, we got a number answer. Here, we're wanting to write sine as cosine or cosine as sine. So if it's written in sine, we're going to rewrite it as cosine. If it's already written as cosine, we're going to rewrite it as sine. And this is going based off the fact that sine of A is equal to cosine of 90 minus A, or cosine of A is equal to sine of 90 minus that angle. Or as I think most of y'all ended up saying, we're just taking whatever the angle is and subtracting 90 from it. So if we look at 36, it's sine of 67. So for this one here, that'd be the same as cosine of 90 minus 67. And 90 minus 67 is? So the answer would be cosine of 23. That's it. It's not actually asking us to find what cosine of 23 is. It's just rewriting sine as, or cosine as, sine. So the next one here, 37, we're going to have sine of an angle. And again, that angle is going to be in parentheses. It's not going to be equal to it. So it gave us 3.2. So really we're saying that this is the same as sine of 90. Seven, 86, yep, 86.8. Because we could do the adding up method of kind of solving this. Because if we're at 3.2 and I want to get to 90, 0.8 will take us from the 3 to a 6 would take it from a 4 to 10. And to get from 10 to 90, I need it to be in 8. So we're just adding up to it. For 38, so yes, we would have cosine of 88, because 90 minus 2 is 88. And the next one, we would have sine of 34, because 90 minus 56 is 34. And that's all we have to do for these here. Any questions on 36 through 41? And again, I'd make sure that I have those two equations written down into this section. Find the exact value of each expression. We could plug this in. Most likely, yes. There are some restrictions that do occur, but we won't see them in the angles we're looking at. 0 to 90 for sine, cosine, and tangent, the inverses work out nicely. Once we get past 0 to 90, either going with negative angles or bigger positive angles, there's stuff we have to manipulate with it. It won't always work out to be just like this here. But for the ones that we have, and again, if we plugged it in, second sine inverse of sine of 81 is 81. So again, even if you don't remember that, typing these straight into the calculator will still give you the answer. And if you're not sure, especially on the test when you hit this point, type it in. It'll give you the answer. Especially when it's saying evaluate or find the exact value. 45 through 50. 45 through 50. Inverse. Because for 45, the only way I can undo sine of A to get A out is with sine inverse. Taking sine inverse of both sides. Because here sine and sine inverse will cancel, telling me that A is equal to sine inverse of 0.7436. Go at least one decimal place, if not two. Because if you don't feel comfortable, or if you've got it far enough, give me as many decimal places as you want. Because it's never a bad thing to give me too many than too few. Because especially if you get off 2 or 3 decimal places out, I'm more likely to give it to you. But if you gave me, say, 49.7 instead of 48.03, I'm going to mark it wrong. If you gave me 48.56 instead of 48.03, okay, I'm most likely going to give it to you. Because if you're within reason, I'll give it to you. If you're more than a half a point away, most likely not. Well, if we look at 47, we're going to do almost the exact same thing, but we're not using sine inverse. We're going to use tangent inverse because it gave us tangent of A. So to undo sine, we use sine inverse. To undo tangent, we use tangent inverse. And if we type that in, tangent inverse of 0.9874, we get Any questions on these here? You can round if you want, or if you don't want to, that's fine. If you rounded to the first decimal place to the 6, as again, whenever we round, we always put a 0 next to the number that we rounded, just to signify that we did round. And 49, if we work this out, we would see that A is 30 degrees exactly. That's one of, no, it's one of the special cases. Because if we take sine inverse of 1/2, I believe it is 30 degrees. Which, if we do it in the Trigger pre-calc class, they do have the right-hand method that actually goes over the values of sine, cosine and cosine for 0, 30, 45, 60, and 90. But it's not a big of an emphasis at this point. Any other questions on 45 through 50? Well, 45 through 50, again, is just typing it in, but instead of as it looks, we have to use the inverse for the other side. If there are no other questions on those, we'll look at 51 through 56, and we're actually almost done. Now, 51 through 56, we're using sine, cosine, and tangent. Well, sine of an angle is equal to opposite over the hypotenuse. Cosine of an angle is adjacent over the hypotenuse, and tangent, yep, tangent is opposite over the adjacent. So it'd be good to have these down, especially for this here, because we're needing sine, cosine, and tangent to find these side lengths. And we can't use the shortcuts because all of these here, well, we could if we did have 30, 60, 90, or the 45, 45, 90. Now for 51, they give us the angle of 36 degrees. We could find the other angle because, again, any three angles in a triangle add up to be 180. But just looking at this here with this given angle, what side lengths are we given or looking for? We're given the hypotenuse. We're given the side opposite 90 degrees. So it means I'm either using sine or cosine, one of those two. Now, from the given angle, Are we trying to find the side opposite it or next to it, the adjacent? What are we trying to find? It's next to it. So we are given the hypotenuse and we're wanting to find the adjacent side. So we use sine or cosine? Cosine. So we're saying cosine of 36 degrees is equal to the adjacent side over the hypotenuse. So we multiply both sides by the bottom of the fraction, which would be 27. And we multiply both sides by 27 here. They cancel out, telling us that 27 cosine of 36 is equal to, is the variable by itself. Yes, so we can plug it into the calculator. So we can type in 27 cosine of 36. I'll take 8.4 or 8.5. I will take both. I'll take both of those. Yep. Because since it doesn't specify if we round or not, you can round to the nearest second decimal place or leave it. Either way. And that's it. Any other questions on 51? Let's look at 52. So if we look at problem 52, we're given the angle of 56. We're given also that one side is x and one side is 17. Which one of these are we given the hypotenuse? Here's the right angle, yes? So we're still using sine or cosine because the hypotenuse is always opposite the right angle. So we are given the hypotenuse. Now the other side length that's given is 17. Is that adjacent to or opposite the angle? It's adjacent. So here we're still using cosine. So cosine of 56 degrees, the adjacent side of 17 over the hypotenuse. And again, the reason I wanted to look at this one here, because unlike the last one, we're actually, solving for the hypotenuse. But the overall steps that we do, at least for the start, doesn't change. Because we're still going to multiply both sides by the bottom of the fraction, which would be our x. Well, the x and x here would cancel, telling me that I have x cosine of 56 is equal to 17. Is the variable by itself? No, because we have x times cosine of 56. So, okay, we have one more step. We need to divide both sides by cosine of 56. These cancel, telling us that x is equal to 30.40, because we can type in 17 over cosine of 56 into the calculator to get our answer. Any other questions on this here? Questions on 53 or 54? Because for any of these here, using sine, cosine, or tangent isn't really going to change. We're just needing to make sure we use the correct one for the given setup. Because if we're given the opposite and hypotenuse, we're using sine, because sine of an angle is the opposite over the hypotenuse. Cosine of a given angle is, guys, And tangent of a given angle is opposite over the adjacent. So when we figure out which angle that's given, we need to see how do the sides relate to that angle. Now we know for sure if we're not given the hypotenuse, we have to use tangent. So 54 would be tangent, because tangent of 56 is equal to the opposite side length x over the adjacent. And here we would multiply both sides by 14, telling us that 14 tangent of 56 is equal to and again at this point here we can multiply or plug into the calculator 14 tangent of 56 and it would give us our answer. Any other questions on these here? Any other questions on any of these here? All right. And I believe that brings us to the last three, 57 through 60, yes? Yeah. Let's see here. Yep. Now on these here, we're having to find the one missing side and the two angles. We're trying to find the one missing side and the two angles. Now we can look at 57 first. Well, anytime we're given two sides of a right triangle, we can use the Pythagorean Theorem to find the third. So for 57, we're going to end up using our a squared plus b squared is equal to e squared. So we're saying 15 squared plus 20 squared is equal to our hypotenuse, which is our x squared, or we can leave it as c squared, either one. Now at this point here, we do have the 15 squared and 20 squared, both of our numbers on the same side. So we could just plug that in. If we plug it in, we get 625. Because, well, 15 squared is 225. 20 squared is 400. And 400 plus 225 is our 625. Now at this point here, we would square root both sides, telling us x is equal to 25. Any questions on how we found this here? Okay. Bless you. Now that we've found the hypotenuse, we need to find the measures of x and y. And it really doesn't matter which one we use first. So say we wanted to find the value of x first. Because tangent is going to be opposite over adjacent. So for angle x, do we have the opposite adjacent sides? Could I use sine? Because sine would be opposite over the hypotenuse. We have those. We could use cosine. It doesn't matter. But since y'all said tangent first, we can use tangent. The real key is making sure the side lengths that we put into the fraction are the correct side lengths. So if I'm using tangent of x, opposite side would be, and the adjacent side is, and then we apply tangent inverse to both sides. Because tangent and tangent inverse will cancel, telling me that the angle x is equal to tangent inverse of 20 over 15. And if we type this in, we get 53.13 degrees. Now the two acute angles in a triangle add up to be 90. All three angles add up to be 180. Well, we understood one is 90. 180 minus 90 gives us 90. So we just need to subtract these two here. Give us 87. That'd be 8, 9, 9, 10. So if we do the subtraction, we should get 26.87. Or 36, yes, thank you. And again, you could have done that straight in the calculator, 90 minus 53.13, and get this here. So really on these here, we're really just using Pythagorean theorem to find the missing side length, using the inverse functions to find one angle, and we can subtract it from 90 to find the other. Any other questions on this here? Let's do one last one. Let's do 58. Because for 58, we can use the Pythagorean theorem to find the missing side length. For a squared plus b squared is equal to c squared. So we'd have 36 squared plus c squared is equal to 65 squared. So we do need to be careful to make sure that we're not assuming that it's always going to be the hypotenuse that we're finding. Now 36 squared is 1,296. 65 squared is 4,000. So we can go on and square the 36 and 65. We can figure out what those two are. Now at this point here, we can subtract 1,296 from both sides, which will tell us that z squared is 9. And if we square root both sides, yeah, we can say z is 54.1 degrees. If we wanted to leave it as a radical, we could have done that also. Any questions on how we found the measure of z? I need to change 57 because I can't have that mean side length x and angle x, but whatever. Now looking at 58, because again, we can use sine, cosine, or tangent. Personally, I'm going to solve for x. Well, we can solve for x or y. We can solve for x first, and I'm going to either use, actually, I'm mainly going to stick with sine. Because sine for this one here, sine of x is equal to what over what? Opposite, which is? I'm just picking the one that doesn't use the approximated number, so I get closer to the exact answer. Now we do the inverse to both sides, applying sine inverse. And here sine and sine will cancel, telling us x is equal to sine inverse of 36 over 65. So take 90 minus 87.75, which would be 2.25. There's quite a depravity between those two. I could be right, because we're on 58. Try that again. Yeah. For x, yeah, because that seemed a little big. So for sine, you got what? 0.63. And if we do 90 minus 33.63, 73. 56.37. That makes a little more sense. Because for that angle to be 88, it would mean one of the side lengths, not the hypotenuse, because it's always going to be the biggest, but the two legs, one of them should be really big and the other should be really small. Because if you remember back to the homework assignment where we had that really small angle, well, the side length that we ended up finding was really big. Yes, but that's it. Because again, when we talked about the properties with sides and angles, guys, focus, pull back in here. Come back in here just for a second. Because when we talked about angle proportions with side lengths, the biggest side is always opposite the biggest angle. Smallest side's opposite the smallest angle. And they kind of stay in that proportion. So if one of the angles is decently bigger than the other, we'd expect the side lengths to have a decent gap between them. Well, this here, 54 and 36, they're still pretty close overall. So the angles are still kind of close together. For us to get 88 and 3, they need to be vastly different. Because if one of them was 56, the other we're looking for probably in the 10s or around 10 to have a decent gap between them. But that's it.